For today, let's look at this interesting number theory problem. This problem involves p and n as shown. Suppose p is a prime and p is more than 3. Show that for any integer n that is greater than 1, n to the power of p squared plus 1 plus n to the power of p squared plus 1 is not a prime number. Please give it a try before you look at the answer. From the condition, p is prime and p is greater than 3. We may want to think of what is so special about 3. With this condition, p is congruent to plus or minus 1 mod 3. And now we know that p squared is congruent to 1 mod 3. As such, we'll let p squared equals to 3k plus 1 for some integer k. And therefore, p squared plus 1 equals 3k plus 2. Now, we write the original expression, that is n to the power of p squared plus 1 plus n to the power of p squared plus 1 equals n to the power of 3k plus 2 plus n to the power of 3k plus 1 plus 1. Now we let this expression as j. We will rewrite this expression again by adding minus n squared plus n squared and minus n plus n in some order. This expression still equals to j. As shown, the first two terms can be written as n squared times n to the power of 3k minus 1. For the next two terms, n times n to the power of 3k minus 1. And combine the last three terms, that is n squared plus n plus 1. So the first part of the expression can be factorized as n squared plus n times n cubed to the power of k minus 1. We are going to show that the first part of the j is a factor of n squared plus n plus 1. To see this, we need to recall that x to the power of n minus 1 can be factorized as x minus 1 times x to the power of n minus 1 plus x to the power of n minus 2 all the way to 1. For number 2, y to the power of 3 minus 1 can be written as y minus 1 times y squared plus y plus 1. With this, n to the power of 3 to the power of k minus 1 can be written as n to the power of 3 minus 1 times a polynomial qn. In this case, we are using the first result by putting n cubed equals x. Let's continue. From this, we will have, for n cubed minus 1, we can write as n minus 1 times n squared plus n plus 1. So as shown, now we combine the n minus 1 and qn as rn. So this expression can be written as n squared plus n plus 1 times rn. Let's go back to the expression j. The product of the first part can be written as n squared plus n plus 1 times some polynomial gn. With this, we can factorize again n squared plus n plus 1. The rest we can write as hn for some polynomial hn, where hn is an integer that is always greater than 1. With this, we show that j cannot be a prime number because it is a product of n squared plus n plus 1 and some integer that is greater than 1. I created this problem based on a question saying that n power 5 plus n power 4 plus 1 is not a prime number for any n greater than 1. And also, for any prime p greater than 6, it is congruent to plus minus 1 mod 6. I combine these two results to create today's problem. Hope that you learned something new today and enjoyed this video. That's all for today's lesson. I'll see you again next time. Bye bye.